So we're kind of going back to that for just a little bit, and we're going to look at infusion time and infusion volume. Infusion time is how long did it take for the number of milliliters to run, okay? So we're looking for the number of hours. That does that to me every time I try to start something different. I've lost my mouse again. Okay, so infusion time is hours. And then the volume is the total number of milliliters that have ran, or infused is a better word to use there. Over so many hours. Or it could be minutes, but we're looking mainly at hours. So this is for number 24, we've got an order for 1,000 milliliters to run at 125 milliliters per hour. So it says, how long will this last? So I'm looking for time in hours. And sometimes we'll have minutes. And I'll show you how to work that one. All right, so I've got 1,000, stupid pen. So I'm looking for hours. I've got 1,000 milliliters. And it's running at a rate of 125 milliliters per hour. So I'm looking for the number of hours it's going to run. So we set it up similar to how we set up our flow rate, except this time it's our total number of milliliters times our rate. So the milliliters cancel. And I'm going to look at how many milliliters are in an hour. So I'm going to take 1,000 and divide it by 125. And it's going to take 8 hours to run. So that's my infusion time. So it is just the total number of milliliters you have times your rate. If my rate is in drops per minute, I'd have to do my drop factor conversion, but I could still find the total number of hours it would run. So number 25 has the infusion time in hours and minutes. So this one's a little bit different, but we're still using our total number of milliliters times our rate. So this time, I'm going to have the 500 over 1 times my 1 hour over 90. My milliliters will cancel. So I'm doing 500 divided by 90. And I get a repeating decimal. I get 5.5 repeating. So if I round that, it would be 5.6, because that would be 5.55. So I have 5.6 hours. Well, I want to know my number of minutes. So I know I have 5 hours, but then how many minutes do I have? So to find the number of minutes, I'm going to take the 0.6 hours and I'm going to convert it to minutes. So I'm just using a time conversion. 60 minutes over 1 hour, because I want my hours to cancel. And I want it in minutes. So 0.6 times 60 gives me 36. So I've got 5 hours and 36 minutes. All right, I'm going fast this morning, so I'm sorry. But any questions on 24 or 25? Y'all have to speak up because I can't see if you raise your hand or anything online.
Yes, ma'am. I'm sorry.
Okay.
Where did you get the 0.6 from?
When I rounded the 5.55 right here.
Yes, ma'am.
Okay. The 0.55 will round to 0.6. So I'm just taking the 5 off to get the 0.6 because all I want to look at is the decimal number because the 5 is my hours and I'm taking it out over here.
Okay.
Okay. Does anybody else have a question? All right, let's look at 26. All right, at what time will this IV complete? So this I'm looking a little bit different. I'm going to have to find my hours first because I got to know how long it's going to take. But the time is considered a conversion time, or not a conversion, completion time. My husband's in here making comments. So my completion time is my clock time. So at what time will this be complete? I'm wanting a clock time, but I have to find my hours first. So we're going to start it out just like we did the other two, looking for hours. I've got 1 liter. We know 1 liter is 1,000 milliliters. So I'm going to start with that. And then I've got 60 milliliters per hour. So I'm going to do 1 hour over 60 milliliters. So still total milliliters over my rate. My milliliters cancel. I can cancel a 0. So I've got 100 divided by 6. And that gives me 16.67. So if I round that one, that's going to give me 16.7 hours. So again, I've got a decimal. With the decimal, I have to find my minutes. So I know I have 16 hours. So I'm going to take this away and put it over here. And that becomes a 0.7 hours. So I'm going to look for how many minutes I have. So to find my minutes, I have enough room on these, bless you. I got 0.7 hours. I'll write that a little neater. Times my 60 minutes over 1 hour. So 0.7 times 60. And that gives me 42 minutes. Now, sometimes you'll have to round these to the nearest 5 minutes, or nearest 5 minutes. So that would round to 40 minutes, or we could round it to 45. But for this, I'm just going to leave it at 42 minutes. So 16 hours and 42 minutes is my infusion time.
Is the 60 minutes is over an R?
Over an hour. That's an H.
Oh, okay.
Okay. With this pad, my handwriting's bad anyway, but it's really bad with this pad. All right. So now to find the completion time, we're going to take our start time. So if it begins at 0600, that's our start time. Then we're going to add our hour. And remember, in 24-hour clock time, military time, whatever you want to call this, the first 2 digits is our hours. The last 2 digits is our minutes. So I got 42 minutes. And I'm just going to add those together. So it gives me 42. 6 and 6 is 12. So I add 1. 1 and 1 is 2. So my completion time, or at what time will the IV be completed, is at 42,400. Okay, or 2242 hours, some people says. So we did several things in this one, but it's the things that we did in the first 2, and then we added the completion time. So any questions on this one? Okay, Okay, so I'm going to take that as a no. All right, let's look at 27. And we have at 1600, the nurse started the IV, which is 1200 milliliters at 100 milliliters per hour. So this time we're going to calculate the infusion time and the completion time, which is the same thing we just did on 26. So to calculate my infusion time, pin color didn't change. All right. So I'm looking for hours. I got 1200 liters times my rate, which is 1 hour over 100 milliliters. So I can cancel my zeros. So 12 times 1 gives me 12 hours. My milliliters cancel also. So this one doesn't have a decimal, so there's no minutes. It's just 12 complete hours. If my IV started at 1600, so my completion time starts at 1600. I'm going to add my 12 hours. Since I didn't have any minutes, I'm going to put the zeros. I'm going to add those two together. 6 and 2 is 8. 1 and 2 is 2. Now, here's something. We don't have a 2800 on our clock time. Okay? So this started at 1600 and it's went into the next day, into the next morning. So to find our actual completion time, we have to subtract 24 hours and no minutes. So we're subtracting 1 day because it's gone past midnight into the next day. So 2800 minus 2400 gives 400, and this would be my completion time. So it's going to complete at 4 a.m. the next morning. And this is my infusion time. Okay, so anytime you have a completion time that's greater than 24 or 2400, you're going to subtract 2400 from it because we got to cross that midnight hour. So is there any questions on this? Okay. Let's look at 28. And it's the same type of thing. It starts at 1315. We have 1500 milliliters to run at 125 milliliters per hour. So I want the infusion time and the completion time. So I'm going to give you all a few minutes to work this one. Okay, so I don't know what I was doing. I'm going to work this one for you so you can compare. Okay, I have got 12 hours as my infusion time and 0115 or 1500 hours, however you say that. So did everybody get that?
No, I didn't.
No.
So we have any questions? Okay. So this is easier than what we did last Monday, isn't it?
Yes, ma'am, actually.
Okay. So that's it on chapter 15. Okay. So that's my infusion time and my completion time. And if I need to convert it to minutes, if I've got a decimal, I have to convert it to minutes. One thing I didn't do is what's my total volume. So I'm going to add a page in here. Give you screen. Rowdy hush. Put my 115 back up here. All right, so if I'm going to call this 29. If we have an IV that infuses for 7 hours at 65 milliliters per hour, the question's going to look something like how many milliliters have infused, or how much volume has infused.
No, tell her. No, tell her.
Rowdy, you're not going outside. You're not going outside to chase a cat. Okay. So to look for my volume, I'm looking for milliliters. I'm going to take my infusion rate at 65 milliliters per hour times my infusion time, which is 7 hours. So my hours cancel, and then I have 65 times
No,
7,
I didn't.
and I have 455 milliliters that have infused. I did the math right. So you can also calculate on the percent of variation. So going back, thinking about the percent of variation, to know how much you have if you're running at a drop factor or a drop rate of, say, 84 minutes or drops per minute. Oops. Yeah, question? I'll write this better. So if I have a rate of 84 drops per minute, and it's ran for 4 hours of the 8 hours total, so it's ran half a time. And let's say I'm infusing 1,500 milliliters, and I'm making this up. And I want to know how much IV solution should I have left. have remaining. Okay, my drop factor is going to be 20 drops per milliliter. So to find out my milliliters, I take my rate of 84 drops per minute times my time, which is 4 hours. And then since I'm going from minutes to hours, I've got to have the 60 minutes over 1 hour. And then I've also got to have my drop factor in here. So I'm going to write it upside down though, because I got drops on top and I'm looking for milliliters. So 20 drops goes on bottom. So my minutes cancel, my hours cancel, and my drops cancel. And then I can cancel 20 goes into 21 and 20 goes into 63 times. So I'm multiplying 84 times 4 times 3, or 84 times 12. And it's infused 1,008 milliliters in my 4 hours. And so it's running way too fast because I'm more than halfway through my 1,500 milliliters. So that's one way, you know, you'd use the how much is remaining, and that's also how you solve it with drops per minute when you have a rate in drops per minute. So any questions on this? Do I need to do another one with drops per minute?
Yes, ma'am, please.
Okay.
Yes.
So let's look, I'll call this one 31. And let's say we have this time 33 drops per minute with a drop factor of 15 drops per milliliter. And it's going to run over, let's say 3 hours. So how much IV solution do we have left? I want to say remains, I want to say infused. So how much has gone through the IV? Okay, so I'm still looking for milliliters. I've got 33 drops per minute. I'm going to set this up a little bit different. I'm going to go ahead and do my drop factor next. It doesn't matter if I do my drop factor or my hours next to my hour conversion. It's all got to be done. But then I'm going to have 1 milliliter over 15 drops times my time it's ran, which is 3 hours. And then my time conversion from hours to minute, 60 minutes over 1 hour. Okay, that way my hours is canceled, my minutes is canceled, my drops are canceled, and I'm left in just milliliters. Now I'm going to go ahead and cancel 15, goes in 15 once, 15 goes into 60 4 times. So I'm going to multiply together 33 times the 1 times the 3 times the 4, and that will give me my milliliter. So 33 times 3 times 4 gives me 396 milliliters. Okay, does that make more sense?
Yes, ma'am.
Okay. So any other questions on this? So that's it for 15. And Do you have questions on anything on 15 that I need to go back over? Doing the percent of variation or the infusion rate, the IV push, the flow rates for drops per minute or flow rates per hour. Do we need to redo any, or do I need to work any of those for you?
Definitely the flow rate.
Which one?
The one, the flow rate, the drops per minute, the right when you're on.
Okay, sorry, there's an echo. Say it one more time. It's the drops per minute flow rate, but for what?
Yes, ma'am, that one. Is it the, I think is this the one that's showing like drop factor? I don't know if I don't know which one.
Is it the one that doesn't have the drop factor?
Hold on just a second. Let me see which one.
Okay, so say, see if you can remember which one it was.
Oh no, I don't think that was. That's okay, because I can't find which one I'm talking about.
Right. When you find it, if you want to email me the question, I'll work it and send it to you.
Okay.
Okay. And just because I found number 7, I know I've said this, but number 7, I've got the order for ampicillin. It's 100 milliliters to infuse over 45 minutes, but the drop factor is missing. Okay, so there's no drop factor. When there's no drop factor, you've got to call the physician or call the doctor for clarification. So if any part of the order, I can't spell clarification this morning. If any part of the order is missing, drop factor or anything, then anything that you need to calculate, at least for this class, then you've got to call the doctor for clarification or just call the doctor. All right. So if you got any questions, even if it's a specific question over the homework, even email me the question. Don't email me the number. Email me what the question says, because there's a question bank that I pull the homework from. So everybody's question number 6 is not going to be the same. So if you'll email me the question, then I can email you the answer.
Is this something you're going to be posting? Because I don't have anything posted for chapter 15.
I will. Are you talking about homework or talking about?
Like an actual assignment, like that we have to submit. I don't have anything that we have to submit on chapter 15.
Okay, let me check. I thought I had the homework opened. Yeah, look in week 12. It should be open now. And there's chapter 15, intravenous solutions. I can edit that and make it say homework. And that might be what's confusing you, because it doesn't say, it just says put homework on there. So you may have to update your page, but now it says chapter 15, intravenous solutions, homework, and it's due November 23rd, but it's in week 12.
Oh, okay, I was looking at week 11. I thought we were
Okay.
supposed to do that already. My bad.
Well, we probably were supposed to, but we're fine. All right, so let's look at chapter 16. And we start, 16 is body surface, medications based on body surface. So our body surface area, which is meters squared. So like in chapter 13, where our dosages were based on kilograms, this time our safe dosage is based on kilograms. This time our safe dosage is based on a person's body area, body surface area. And you can calculate the body surface area in 2 ways. We can calculate it using centimeters, or using metrics rather, centimeters and kilograms. or we can calculate it using inches and pounds for height, for weight. Now, notice the difference. If we're using centimeters, we're dividing by 3,600. If we're using inches and pounds, we're dividing by 31. So the division's different. It's still height times weight divided by either 3,600 or 3131, and it's the square root of that answer. Now, I will try to remember to give you the formulas on these. But if you want to make a note card with this formula on it to use on the Chapter 16 homework and the Chapter 16 or the test over this, then that's fine with me. Because this is one formula I don't expect you to memorize, but I expect you to be familiar with it. So to look at these, so the first thing you're going to do is you're going to look at your problem. It says calculate the BSA of an infant. The first couple of problems is just the BSA, calculating the BSA, whose length is 50 centimeters and the weight is 3.2 kilograms. So that means that I'm using the BSA that uses centimeters and kilograms. So the BSA is meters squared. And I'm going to take the square root of my answer of this, my height in centimeters, which is 50, times my weight in kilograms, in this case is 3.2, over the 3,600. Okay, so I'm just kind of plugging in my numbers, and that's what this one is. It's just you plug and chug. You're going to plug in your numbers for your height, your weight, and then what I'm dividing by. I'm going to work what's inside the square root first. Take the square root of that answer last. So, find my calculator again. So I'm doing 50 times 3.2, and that's 150. Divide that by 3,600. And I get the square root of 0.0417. We're going to take it out to 4 decimal places. And I'm going to have a different calculator. Now, if you take your phone, if you got an iPhone, if you don't have a calculator, it's got a square root button. If you take your iPhone and turn it sideways, you should have a square root key. And to put it in your iPhone, I lost my pen again. So to put it in your iPhone, you're going to do the 0.0417 and then hit your square root key. And I think it's square root of X. If you got a calculator, it depends on the calculator too. Some of them you may have to do the same way I did for the iPhone. Some calculators you can do the square root and then put the number in it. So if I take the square root of the 0.0417, I'm going to get 0.2042. And I want to round this to 2 decimal places. Okay, our meter squared is 2 decimal places. So I'm going to look at the 4, doesn't change the 1. So it's going to be 0.20 meters squared. So normally we don't do the trailing zeros, but on this one we're going to, with the BSA, we can do the trailing zero.
Did you get a lot of numbers after that?
Yes. I just stopped at 4 decimal places.
Okay.
Okay. I actually got 0.2042057786.
Yeah, I mean,
Yeah. Okay. So finding the BSA is really, it's just plugging it in and seeing where it all is. So, Rowdy, hush. He's trying to protect us from those leaves outside, I think. All right, so let's look at number 2. We have a child whose height is 42 inches and has a weight of 70 pounds. So our meters squared, our BSA, and I'm just going to write it here, is our weight, or not our weight, it starts with our height. So our height in inches times our weight in pounds over 3131. Okay, so we don't have to convert anything. We're just going to use a different formula. So my height is 42 times my weight of 70 divided by 42. Not 42. What am I thinking? 3131. So again, I'm going to work what's under the square root first. So I'm doing 42 times 70. And I get 2940. Going to divide that by 3131. And I want to get 0 point, and again, I'm only rounding to 4 decimal places, 93.8. So it goes 0.938997. So that's going to make this 0.90 when I round it. So take the square root of that. 9390. And I'm going to get 0.9690. Round it to 2 decimal places, so 0.97 meters squared. And that's my body surface area. My camera's off. My camera is off if you need to go through. Okay.
Sure.
All right. Okay, so questions? All right. So let's look at 3, and I'm going to get you started on it, and then I'm going to let y'all finish it. But I've got a height of 5 feet 9 inches and a weight of 86.6 kilograms. So I've got to convert either the 5 feet 9 inches has to be converted to inches, and the 86.6 kilograms has to be converted to pounds. Okay. So we got to do it one way or the other. Well, this has to be converted to inches, even to convert it to centimeters. So I either have to convert the height to centimeters or convert the kilograms to pounds. I think I'm going to convert the kilograms to pounds. But to convert my 5 feet 9 inches to total inches, I've got to take my 5 feet and I'm going to times it times, I'm going to write this out instead of using my hash marks. Take the 5 feet, put it over 1. There's 12 inches in 1 foot. So my feet cancel, and I do 5 times 12, which is 60. And then I'm going to add my 9 inches back in. So my 9 inches. And that gives me a total of 69 inches for the height. So to convert that to, I was going to convert the 86.6 kilograms to pounds. So I'm going to take 88.6 kilograms over 1 to convert it to pounds. Remember, there's 2.2 pounds in 1 kilogram. So my kilograms will cancel. Multiply the 88.6 times the 2.2. And I get 194.92 pounds. So I can say 195 pounds, and that's rounded. So now I have pounds in inches, and I can use the pounds and inches for the BSA. So now that I have everything converted, I want y'all to work it and see what you get for the BSA. So basically, you're plugging it into the formula. Okay, I'm gonna go let the dog out. I'll be right back.
Okay.
Okay, so did you all get 2.07 meters squared for your BSA?
So we're not supposed to round up?
Say that again, I'm sorry.
I got like 2.1, so we're not supposed to round up?
You round it to 2 decimal places.
Okay.
I would have taken 2.1. I'm not that picky, as long as you showed me what you did. And that equals that. Okay. So we all good still? Maybe?
Yes.
Maybe. It'll come second nature to you eventually. Okay. So let's look at number 4. And this one is we're actually going to end up calculating, is the dosage safe? Okay. So we're going to do real similar to what we did in chapter 13. So we have a child that's 121 centimeters tall, and it weighs 23 kilograms. So this one's in centimeters and kilograms. I don't have to worry about converting anything. And then the drug order reads, whatever that medication is, at 1.8 milligrams. So this is my order. And they're to give it at 10 a.m. Is this dosage safe for this child? Why or why not? Why or why not? So I want to know, is it safe? And then it tells me, though, on the package insert, the recommended dosage, as noted, is 2 milligrams per meter squared. Okay. So first thing I want to find out is, what is my BSA? So since it's in centimeters and kilograms, my BSA is going to be the weight. I'm doing that backwards again. It was the weight. It's 23 times the weight, which, or the height, which is 126, divided by 3,600. Now, if you multiply the height times the weight, it doesn't matter because you're multiplying. You're going to get the same thing if you do 23 times 126 or 126 times 23. You're still going to get $28.98 or $2,898. Still going to divide it by 3,600. So I'm going to take the square root, and this one was just 3 digits, so it was 805, 0.805, so I don't have to round that to anything. And then so my MSA, when I round it, I've got 0.0897. I've got a whole bunch of numbers after that, but I'm stopping there. So my MSA is, the 7 makes a 9, round to 10. So it's 0.90 meters squared. Now, you can use 0.90 or you can use 0.9, either way. It's the same amount. Okay,
So that was,
go ahead.
I'm sorry. Go ahead.
Go ahead and ask.
So that was it.
That's it for the MSA.
Okay.
Okay. Now, to find the recommended dosage, and I left out a word, the recommended safe dosage for this child. Okay. I'm going to use my 2 milligrams per meter squared and my BSA. So the safe dosage, and I want it in milligrams, 2 milligrams per meter squared times my 0. Put that in green so it kind of goes together. Times the 0.9 meters squared over 1. So my meter squareds cancel, and I've got 2 times 0.9, which gives me 1.8 milligrams. So this is my safe dose. So remember that your ordered dose or your order dose is less than or equal to your safe dose. So my ordered dose, where do you go? Is this 1.8 milligrams here. And is it less than or equal to my safe dose, which is 1.8 milligrams? So that's a true statement, right?
Yes.
Yes. So then my dose is safe. So the recommend, or well, put that in the wrong place. It says, is the ordered dose safe? And I can add a yes, it's safe. So why is it safe? It's safe because the ordered dose is equal to the safe dose. Any questions on that one?
No, ma'am.
Okay. Have I confused y'all yet?
Actually, that was the easiest one for me.
Me too.
It's because you've seen this. You've seen this before. We just, I mean, because we did it with kilograms or milligrams per kilogram, and now we're just doing it milligrams per meter squared. So we've done the process before. So that's one of the reasons it's easier. And that chapter 15 is just complicated. So this feels so much easier.
The what you say, the medium some squared seem easier than the formulas.
Yeah. It's milligrams per meter squared is what our safe dose is on this one. And the other, in chapter 13, it was milligrams per kilogram.
Oh.
And they're both per dose, so. All right. So going on to this one, if our safe dosage, if the dosage is safe, and it was, how much will we give? And always when I'm asking how much will we give, that's for one dose, not how many milligrams. And since the dosage is not safe, we're not going to worry about it. But if the dosage is not safe, you always call the doctor, call the physician. So remember, when you're looking for how much you will give, and it's been a while since we kind of done this. In this case, it's in milliliters, so I'm looking for the milliliters, looking for one dose. It's my ordered dose, or my doctor's orders. So the ordered dose over 1 times my supply dose, or my form, over my dosage strength. So in this case, it's going to be milliliters over milligrams. So my ordered dose was 1.8 milligrams, and that's from this previous problem. And then that over 1. My supply is 1 milligram per milliliter. So my form is the 1 milliliter. My dosage strength is the 1 milligram. My milligrams cancel. So 1.8 times 1 divided by 1 is 1 milliliter. This should be pretty easy for you too, because that's what we did chapter 10, 11. We've done some of it in 12 and 13. We did we didn't do any of it in 14 or 15 rather. Okay, questions?
No.
Okay, so let's look at 5. So I'm going to let y'all do the BSA. Okay, so you've got 35 inches tall and he weighs 30 pounds. To keep you from having to look back, it's your weight times your height divided by 3131. And this is for pounds and inches. I got 0.58 meters squared for the BSA. Did y'all get that?
I didn't.
You did? Okay. Oh, okay. Oh, sorry.
No.
I work faster. So my ordered dose is 100 milligrams. And we're looking to see, is it safe? And then my drug reference recommends it's 250 milligrams per meter squared every 8 hours. So it just tells me that it's per dose. So now I want to know, is the recommended dose, what is the recommended safe dose for this child? Okay, so remember, my dose, or safe dose, is my ordered dose, or not my ordered dose, sorry. It's my safe dose, recommended safe dose. I'm just going to write it out. 250 milligrams per meter squared times my BSA, which is 0.58 meters squared. So my meter squareds cancel. And I'm doing 250 times 0.58. and I get 145 milligrams. Okay, so remember, this is my safe dose. Is my ordered dose safe?
Yes.
Yeah, it is. My ordered dose is at 100 milligrams. So 100 milligrams has to be less than or equal to my safe dose, which is 145 milligrams. So that's true. So the ordered dose is safe. And it's because the ordered dose, my hand gets ahead of my brain sometimes. So the ordered dose is less than the safe dose. Okay, now I'm gonna let y'all finish this. If the dosage is safe, how much will you give? And remember, this is one dose, always one dose. If the dosage is not safe, which we already know that it's safe, so my supply is in a 500 milligram injection with directions to reconstitute 10 milliliters sterile water for injection. So my concentration is 50 milligrams per milliliter. So my dosage strength is not the 500 milligrams this time. It's the 50 milligrams.
Whew.
All right, so y'all,
Okay, I done got through off now.
you're lost now? It's not good.
Yeah.
Okay, so we go back up here to 5. My ordered dose is 100 milligrams.
Okay.
All right. My supply is at 50 milligrams per milliliter. So how much are we going to give? And that's our milliliters. It's our ordered dose over our supply, 1 milliliters over 50 milligrams. Okay. So 100 divided by 50 is 2 milliliters.
Okay.
Okay. Okay. I think I want to stop there
Mm-hmm.
because the next one goes to per day, milligrams per meter squared per day. And I think I want to stop here because we were doing so good.
Yes.
And we'll pick up with number 5? Number 6 next Monday.
Yeah, this all got to soak in.
Yeah, it's got to soak in.
They do.
We have an hour. It's an hour and 20-minute class. All right, no, an hour and 50-minute class because we stretched out for, we only meet once a week. But we're going to stop here and stop my recording.